In this lesson, we're going to cover area, sector, and arc length in circles. So, let's say we had a radius drawn like so, and another radius, such that these two radiuses were perpendicular to each other. Well, this angle here is 90 degrees. So, that's 1/4 of the full 360 degrees in a circle. So if we want to find this shaded area, we would expect this to be 1/4 of the entire area. Okay, and likewise, if we had a diameter drawn, then this would represent half of the circle. This is 180 degrees, and that's half of the 360, and you can see this is half of the area of the circle. So there's a direct relationship between the angle and the area of the circle. There's actually a proportion that exists between the angle that we have, we'll say is theta, and the area of the shaded region, which we'll call S. The proportion is that whatever the angle is, whatever theta is going to influence how big this area is. The bigger theta is, so if this became bigger, we'd have a bigger area. If it's smaller, like in our diagram here, it represents a smaller area. And the ratio or proportion is whatever the angle is over 360. So theta represents our portion. 360 would be the entire circle. Is the same as the area we're looking for. So this portion of the circle over the area of the entire circle. So, for example, if theta were 90, is 90, we have 90 over 360 equals this area we're looking for over the total area. 90 over 360 is 1/4 equals S over A. So let's redraw this diagram so that we have theta equal 90. We'd have to make the radius come up to here, and we'll just shade in this whole thing. So we're looking for this area here, S. And we have the angle theta. So because this angle is 1/4 of the entire circle, this area, S, will be 1/4 of the entire area, as we see here. So let's do a real example. So let's say this angle here is 40, and this radius is 6. So from our formula, we'll have 40 over 360 equals S over the total area. So in order to calculate S, we have to find the total area first. So area of a circle is pi r squared. Area equals pi 6 squared. So area equals 36 pi. So we have 40 over 360 equals S over 36 pi. Okay, before I cross multiply, I'm actually just going to reduce this. So 40 over 360 is the same as 1 over 9. And now I'll cross multiply. 1 times 36 is 36 pi. S times 9 is 9s. So solving for s here, I'm going to divide both sides by 9. And we end up with 4 pi. So the area of that section S is 4 pi. Okay, so with this formula, we can find the area sector if we're given the inscribed angle theta, and we could find the area of the entire circle. Well, a similar formula exists if looking for the arc length. So the actual length of this arc here. So just like the area sector is related to the total area, this arc length would be a fraction of the total circumference. So the formula would be theta over 360 equals L, the arc length, over the total circumference. So just like before, we'll do a sample problem. We'll say that theta is 40 degrees, and again we'll make the radius 6 inches. So we could plug this in, 40 over 360 equals L over circumference. So we have to calculate the circumference. Circumference equals 2 pi r. Circumference equals 2 pi 6. So we have 12 pi, and this is in inches. So let's plug in 12 pi here. Okay, and again, I'm going to reduce first. You don't have to, but I'm going to reduce this first. So we have 1 over 9. And now I'll cross multiply. 1 times 12 is 12 pi. 1 times 12 pi. And L times 9 equals 9L. So here I'm solving for L. I'll divide by 9. And I'll just reduce this. 3 goes into both of these, so I end up with 4/3. So we have 4 pi over 3 is the arc length.